So I just stumbled upon this pixel physics simulator called sbixel, and wow, it's such a neat little project. It totally blew my mind.
Oh, really? What makes it so interesting? I mean, how complex can a pixel simulator really be?
That's the thing. It's built in Rust using something called Macroquad, which apparently makes drawing super intuitive and simple.
Wait, Rust and simplicity in the same sentence? I feel like I've been hearing Rust is really complicated.
Exactly. That's what I thought too. But this project shows how approachable it can be, especially for someone learning.
That's wild. So what's the core idea behind the simulation?
It uses a sector system to only focus on active areas of pixels. That's a clever way to avoid unnecessary processing.
Right, that makes sense. It's like only worrying about the part of a painting you're currently working on instead of the whole canvas.
Exactly. And it has cool plans for upgrades, like enhancing water simulation and adding gas dynamics.
Wait, it simulates gas too? How does that even work in a pixel context?
Great question. I'm not sure, but it feels like he's looking to mimic how particles might interact, like with wind or buoyancy.
That's actually kind of scary, imagining tiny pixels colliding and drifting like real gases.
Right? And think about the potential. If you add static objects or even refine how water and sand behave, it could get really intricate.
I mean, it's basically creating a mini universe. So what's the current state of this project?
The current setup is pretty basic, just enough to play around and learn from. It's like an experimental sandbox.
And that's fantastic. You can dive in, experiment, and probably even break things without any real risk.
Right. The creator invites contributions too, which is such a neat way to get people engaged in coding.
That makes me think, how valuable is it to have projects like this for learning?
Totally valuable. I think it lets learners experiment in a low-stakes environment, which is key for real understanding.
It's like a playground for code. What's the first thing you'd want to tweak or improve?
Oh, I'd want to enhance that water simulation. Water! It just seems like a fun challenge.
Water physics are notoriously tricky. I can see why that'd be exciting. But what about performance?
Ah, right. They plan to optimize rendering by only processing pixels in active sectors. Super smart.
That's a huge optimization. It's like cleaning up a messy room by only focusing on the spots you use, right?
Perfect analogy. It's all about efficient resource management. But imagine the challenge too.
I can't even. It's easy to let things lag when you're simulating physics. That gives me chills.
Ah, the joys and struggles of coding. But it's also rewarding to witness your creations come to life.
Exactly. And this seems like such a fulfilling way to learn programming concepts dynamically.
Right? I mean, learning like this could really stick. We remember better when we engage with the material.
So true. But here's a thought. What if more educational tools adopted this hands-on approach?
That would change everything. Imagine kids coding their own simulations in school.
Whoa. Now that's an exciting proposal. What do you think the biggest hurdle would be?
Probably access to resources and knowledgeable mentors to guide students through the learning curve.
And yet projects like sbixel could inspire even those just starting. It's accessible, yet deep.
Yes, it's a brilliant blend of entertainment and education. I want to try it out myself.
Same here. Any final thoughts on how this connects to broader learning?
I think it emphasizes the beauty of experiential learning. It can make complex ideas more relatable.
Absolutely, and it poses a great question. How can curiosity drive innovation in education?
That's a thought-provoking takeaway. Let's see how participation in projects like this can spark that curiosity.
Definitely. Here's to more engaging learning experiences ahead. Can't wait to see where these projects go.